Hey there, truth seekers. Ever look at a bridge and think, wow, what a nice way to cross a river? Yeah, well, buckle up because today we're going somewhere your engineering professor definitely didn't cover. Turns out those massive bridges spanning our biggest rivers might be hiding something absolutely wild underneath, like ancient power plant levels of wild. We're talking about structures buried 50 meters below the riverbed that couldn't possibly have been built underwater with 18th century technology. Yet somehow they're there, covered in decorative carvings that should have been above ground. And the best part? The official story makes about as much sense as building a submarine with screen doors. Before we dive into this rabbit hole, and trust me, it goes deep, smash that like button if you're ready to question literally everything you thought you knew about infrastructure. And drop a comment telling me what city you're watching from, because I'm genuinely curious how global this audience is. Are you in London, staring at the Thames right now? New York, walking past the East River bridges? Drop that location below. Because here's the thing nobody wants to talk about. When they drained sections of major rivers for maintenance over the past decade, engineers found something they absolutely were not expecting. Something that got quietly classified, photographed, and then very conveniently buried under concrete before anyone could ask too many questions. Today we're breaking down why your local bridge might actually be a fossil from a civilization that had free energy figured out before someone decided to hit the reset button on human progress. Sound crazy? Yeah, wait till you see the evidence. Let's get into it. So let's start with something most people never think about, which is honestly kind of surprising considering we literally drive over these things every single day. Modern engineers look at historic bridges and see exactly what you'd expect. Transport infrastructure. Road goes here, river goes there, bridge connects the two. Simple geometry, basic physics, nothing to write home about. Except recent investigations are painting a completely different picture, and it's the kind of picture that makes structural engineers very uncomfortable at dinner parties. Underneath every major bridge in Europe and North America, there are massive underwater structures that simply don't make sense if all you're trying to do is hold up a road. We're talking about construction that goes way beyond foundation that keeps the bridge from falling down and enters the territory of, why on earth would you build something this elaborate just to support some cobblestones? These aren't your standard concrete pillars sitting on bedrock. These are intricate, multi-chambered constructions with architectural features that serve no obvious structural purpose whatsoever, which is sort of like discovering that your house's foundation has secret rooms, decorative archways, and a ventilation system that nobody can explain. Not exactly standard building code stuff. The really wild part is that these underwater structures show signs of being designed as complex energy systems, the kind of setup you'd expect from someone trying to harness river flow for power generation. And before you say, well, yeah, hydroelectric plants exist, let me stop you right there. These structures predate the official invention of hydroelectric technology by at least a century, possibly way more. So either we've got the timeline of technological development completely wrong, which would be embarrassing for literally every history textbook ever printed, or something significantly stranger is going on beneath our rivers. Unfortunately for fans of boring conventional explanations, the evidence is leaning heavily toward option 2. Here's where it gets properly weird. What if the entire premise is backward? What if our ancestors weren't building bridges over rivers at all? What if rivers appeared in places where energy stations of an ancient civilization once stood, and those bridges we're so proud of are actually just the visible remnants of something far more sophisticated? It's like discovering that your garden shed used to be a mansion and someone just buried everything except the roof. This theory sounds absolutely bonkers until you start looking at the actual physical evidence, at which point it starts sounding more like the only explanation that makes any engineering sense whatsoever. Think about it this way. If you were going to build a bridge over a river, you'd dig down to stable bedrock, pour your foundation, build your supports, and call it a day. What you wouldn't do is carve decorative patterns into structures that are going to be permanently underwater, where literally nobody can see them. You wouldn't create elaborate chamber systems 40 meters below the waterline. You definitely wouldn't install ventilation networks that serve no purpose for a load-bearing pillar. That's like hiring Michelangelo to paint your basement ceiling and then never turning on the lights. It makes zero sense from a construction standpoint, but it makes perfect sense if those decorative elements and chambers were originally built to be above ground, serving some other purpose entirely. The precision of these underwater structures is another fascinating problem that nobody wants to address. Modern concrete is pretty impressive stuff. We can make it withstand enormous pressures, resist corrosion, all that good engineering magic. But the materials used in these deep foundations exceed modern concrete capabilities in terms of durability and precision. We're talking about stonework, cut and fitted so precisely that you can't slip a credit card between blocks, joined together with techniques that would make contemporary masons weep with inadequacy. This kind of craftsmanship takes time, resources, and, here's the kicker, the ability to work in a dry environment where you can actually see what you're doing, which is pretty difficult when you're supposedly building 50 meters underwater. And it's not just one or two bridges in some obscure European village. This pattern shows up everywhere major rivers exist. The Thames in London, the Rhine cutting through Germany, the Danube winding through Central Europe, the Mississippi and Ohio rivers in North America. All of them feature bridges with these bizarrely overbuilt underwater components. It's almost like someone decided that standard bridge construction was for amateurs and went absolutely wild with the subterranean architecture. Except that explanation requires believing that every bridge builder across multiple continents independently decided to waste enormous resources on elaborate underwater structures that serve no obvious function. Either that's the most unlikely coincidence in engineering history, or we're looking at remnants of a coordinated system that somebody conveniently forgot to mention in the history books. The chamber systems found in these foundations are particularly intriguing. And by intriguing, I mean deeply unsettling for anyone who thinks they understand how infrastructure is supposed to work. These aren't simple hollow spaces. They're carefully designed rooms with arched ceilings, precisely angled walls, and what appear to be channels carved into the stonework. Some of these chambers are large enough to stand in, assuming you could somehow drain the river and get down there without drowning, which seems like it would have been a pretty serious challenge for 18th century construction crews armed with shovels and determination. The official explanation is that these are construction chambers used during the building process, which sounds reasonable until you remember that construction chambers are temporary, and these are permanent features integrated into the structure itself. It's like claiming you built your house around the scaffolding and just left it there for aesthetic reasons. The ventilation systems are even more baffling. Why would underwater foundations need ventilation? Air circulation is great if you're planning to spend time in a space, but it's completely pointless for a solid mass of stone and mortar sitting at the bottom of a river. Unless, of course, those spaces weren't always underwater. Unless they were originally built on dry land and served some purpose that actually required airflow. Like, say, housing mechanical equipment that needed cooling. Or people who needed breathing. Radical concepts, I know, but bear with me here. What really makes engineers nervous? The kind of nervous where they start double-checking their calculations and questioning their life choices, is the energy signature these structures could theoretically produce. Rivers move enormous volumes of water with tremendous force, which represents a massive amount of kinetic energy just flowing past these bridge foundations every single second. If you wanted to capture that energy, you'd design a system of channels and chambers that could direct water through mechanical components, transforming that flow into rotational motion. You'd need carefully angled passages to maximize efficiency, chambers to house whatever machinery you were using, and a way to transfer that generated power somewhere useful. Basically, you'd design something that looks suspiciously like the chambers and channels found in these underwater structures. The math on this is actually pretty straightforward, which is somehow more disturbing than if it were impossibly complicated. A major river like the Thames or Rhine carries enough water volume and velocity to generate serious power if properly harnessed. We're not talking about charging your phone. We're talking about potentially powering entire city districts. Modern hydroelectric calculations suggest that a properly designed system utilizing these existing chambers could produce megawatts of electricity, which raises an uncomfortable question. If the design is this efficient and the rivers are already there, why aren't we using these structures for power generation now? The cynical answer is that doing so would require acknowledging that they were designed for power generation in the first place, which opens up a whole can of historical worms that certain institutions would prefer to keep sealed. There's also the matter of what appears to be distribution systems connected to these chambers. In several documented cases, engineers have found channels carved into the riverbed, radiating out from bridge foundations in geometric patterns that don't match any known construction purpose. These aren't random cracks or erosion. They're deliberately cut conduits running in straight lines toward the shore, almost like someone was planning to carry something from the central structure to multiple locations on land. You know, the way you'd distribute generated power from a central station to various endpoints? Just a thought. Definitely not suggesting anything controversial here. Just pointing out that if you were designing a power distribution network in stone, this is exactly what it would look like. The really frustrating part of all this is how little official documentation exists about these features. You'd think that discovering elaborate chamber systems 40 meters underwater during major infrastructure projects would generate extensive reports, detailed surveys, maybe even some excited academic papers. Instead, there's this weird silence. Engineers notice them, maybe take some measurements for structural integrity purposes, and then everyone just sort of moves on, like finding ancient energy systems under bridges is a normal Tuesday occurrence. It's the engineering equivalent of discovering a secret room in your house and deciding that acknowledging it would be too much paperwork, so you just pretend the door doesn't exist. Compare this to how we treat literally any other archaeological or engineering discovery. Found some pottery shards? Let's write 17 papers about it. Discovered an unusual building foundation? Time for a documentary series. Notice that every major bridge in the Western world has inexplicable energy generation infrastructure built into its foundations? Let's maybe not talk about that because it makes people uncomfortable. The selective enthusiasm is remarkable. It's almost like certain discoveries are interesting only when they don't challenge fundamental assumptions about technological development and historical timelines. The architectural elements found on these deep structures are another detail that doesn't fit the standard narrative. We're talking about decorative carvings, ornamental features, precisely shaped architectural details. The kind of work you do when you want something to look impressive and be seen. Now, I'm not an expert in construction aesthetics, but I'm pretty confident that carving intricate patterns into stonework that's going to be permanently submerged in murky river water is a massive waste of time and resources. It's like writing beautiful calligraphy on the inside of your walls before you hang drywall. Unless, of course, those decorative elements were meant to be visible, because they were originally built above ground level, where people could actually appreciate the craftsmanship. In which case, the question becomes, what happened to raise the water level by 40 to 60 meters? Because that's not a normal, river got a bit higher after some rain situation. That's a catastrophic geographical change. The geological implications alone are staggering. If these structures were built on dry land, then the current rivers either didn't exist or were significantly smaller when construction took place. Some historical maps actually support this idea, showing different watercourses, or none at all, in areas where major rivers now flow. But we'll get to that delightful rabbit hole later. For now, just sit with the concept that the rivers we think of as eternal, permanent features of the landscape might actually be relatively recent additions, like within the last few centuries recent. Which means something dramatic happened to global hydrology that somehow isn't mentioned in any mainstream historical account. Totally normal, nothing suspicious about that at all. The energy potential of these systems is honestly kind of brilliant, which makes their abandonment even more puzzling. Assuming these were designed as power generators, and the engineering evidence suggests they were, whoever built them had solved a major problem that took us another century to officially figure out: how to efficiently convert river flow into usable energy. The chamber designs show sophisticated understanding of fluid dynamics. The channel systems demonstrate knowledge of pressure differentials and flow optimization. And the overall network suggests coordinated planning on a massive scale. This isn't primitive technology stumbled upon by accident. This is advanced engineering implemented systematically across multiple continents, which implies a level of technical knowledge and organizational capability that doesn't match anything we're told about the supposed time period of construction. What's particularly clever about these designs is their sustainability. Unlike modern hydroelectric dams that obstruct river flow and require enormous concrete structures, these systems appear to work with the natural water movement, capturing energy without significantly disrupting the ecosystem. It's almost like whoever designed them understood that you could extract power from moving water without destroying the environment in the process. Revolutionary concept. Completely at odds with how we approach power generation today, where the default setting is build something huge and deal with ecological consequences later. Maybe that's why these systems are conveniently ignored. They represent a paradigm of clean, distributed energy generation that would be really inconvenient for certain industries if people started asking why we abandoned such obviously superior technology. The standardization across different locations is another fascinating detail. These aren't random designs improvised by individual builders. They follow consistent patterns and proportions. The chamber dimensions show mathematical relationships. The channel angles repeat across different sites. Even the decorative elements have common motifs and styles. This level of standardization requires central planning, shared knowledge, and coordinated implementation. In other words, it requires a civilization with the organizational capacity to design, build, and maintain a continent-spanning infrastructure network. Not a bunch of separate kingdoms doing their own thing, but a unified system built according to common principles, which, again, doesn't match the fragmented political landscape we're told existed during the supposed construction period. So here we are, standing on bridges that we use every single day, completely unaware that beneath the surface lies evidence of engineering capabilities that shouldn't exist according to official history. These structures are too precise, too sophisticated, too deliberately designed for specific energy generation purposes to be dismissed as simple bridge foundations. They represent a level of technological achievement that somebody either forgot to mention or actively chose not to mention, which raises some interesting questions about what else might be hiding in plain sight. And before anyone says, well, maybe they were just really enthusiastic about bridge building back then, let me remind you that enthusiasm doesn't explain decorative carvings 50 meters underwater, or ventilation systems serving no structural purpose. Enthusiasm doesn't explain continent-wide standardization or mathematical precision exceeding modern capabilities. What explains all of that is a civilization with advanced engineering knowledge, extensive resources, and a very different understanding of energy generation than we're supposed to believe existed. The question isn't really whether these structures were designed for energy generation. The engineering evidence makes a pretty compelling case that they were. The question is, why this entire aspect of infrastructure has been systematically overlooked, underdocumented, and quietly buried under layers of conventional explanation that don't actually explain anything. It's like everyone collectively agreed that these features are too weird to talk about, so we'll just call them foundations and move on with our day. Unfortunately for that strategy, the structures are still down there, still demonstrating capabilities that shouldn't exist, still generating uncomfortable questions about what our ancestors actually knew and why we've apparently forgotten. And that's just the beginning of this particular story, because if the bridges themselves are this weird, wait until you hear about what engineers found when they actually drained sections of rivers to get a closer look. That's where things get properly wild. Now, if you thought underwater chambers and energy systems were weird, let me introduce you to something that'll really mess with your perception of historical geography. We need to talk about old maps. Specifically, maps from the 1600s and 1700s, because they show something absolutely wild that nobody seems to want to address. Remember how I mentioned that these bridge foundations were built on dry land? Well, the cartographic evidence backs that up in ways that are genuinely unsettling for anyone who assumes our rivers have always been where they are now. Spoiler alert, they absolutely have not. Historical map analysis reveals a pattern that's frankly shocking once you notice it. Major rivers that we consider permanent, eternal features of the landscape, rivers that have been there since forever, according to conventional wisdom, simply don't appear on maps from the 17th and 18th centuries. And we're not talking about minor creeks or seasonal streams. We're talking about the Thames, the Rhine, the Danube, major waterways that move massive volumes of water and define entire regions. On older maps, these rivers are either completely absent, significantly smaller, or running along completely different routes than they do today. It's like comparing a modern street map to one from 50 years ago and discovering that Main Street didn't exist back then. Except way more dramatic because we're talking about geographic features that supposedly take millennia to form. Instead of rivers, these historical maps show something that makes way more sense if you accept the built on dry land theory. Extensive road networks crossing valleys that are currently filled with water. These aren't vague trade routes or suggested paths. They're detailed transportation systems with marked crossings, way stations, and infrastructure nodes. And here's the really fascinating part. Many of these road crossings and transport hubs are located precisely where we now find bridges with those mysteriously deep foundations we talked about earlier. It's almost like someone built a comprehensive ground-level transportation network, and then something happened to flood the entire system, forcing later generations to build bridges over what used to be roads. Just a thought. Definitely not suggesting anything that would upset geography professors. Some of these maps show elaborate infrastructure at the exact coordinates where ancient bridges now stand, except there's no river on the map. There are building clusters, junction points, what appear to be facilities of some kind. Basically everything you'd expect from a functioning ground-level transport hub, with the minor detail of zero water anywhere nearby. This is roughly equivalent to finding a blueprint of your house that shows your basement as the main floor, and everything you think is ground level is actually the second story. The implications are uncomfortable. Either the cartographers were spectacularly bad at their jobs, missing entire rivers while mapping every minor road, or the rivers came later. Given that these are professional maps used for navigation and trade, I'm going to go with option 2, which means we need to have a serious conversation about what happened to create these rivers in the first place. The time frame is particularly interesting. Maps from the late 1700s show one version of geography, and maps from the mid-1800s show our current river systems, which suggests something major happened in between. We're talking about a period of roughly 50 to 75 years, during which the hydrology of entire continents appears to have fundamentally changed. Rivers appeared or expanded dramatically. Valleys flooded, ground levels shifted by dozens of meters in some locations. This isn't normal geological change, which happens over millennia at rates measured in millimeters per year. This is catastrophic transformation happening within a single human lifetime, which should be the kind of event that generates extensive historical documentation, survivor accounts, economic impact assessments, all that good stuff. Except there's basically nothing in the official historical record acknowledging that any of this happened. Now let's talk about the engineering impossibility of building these foundations underwater, because this is where things go from weird to physically absurd. Modern calculations demonstrate that constructing foundations 50 to 60 meters below river level requires capabilities that officially didn't exist in the 18th and 19th centuries. We're not talking about difficult construction. We're talking about impossible construction given the available technology. To work at those depths, you need to remove millions of cubic meters of water from the construction site and keep it removed for years while you build. This requires either cofferdams the size of skyscrapers or pressurized caissons with pumping capacity that wouldn't exist for another century. It's like trying to build a submarine using stone tools and wishful thinking. The physics simply don't work. Let's do some back-of-the-envelope math here, because numbers make everything more depressing. To excavate a work site 60 meters below water level in a major river, you're fighting against enormous hydrostatic pressure, roughly 6 atmospheres of force trying to flood your construction pit. Modern engineering handles this with massive pumps and sealed caissons made from steel and concrete. In the 1700s, the most powerful pumps available were driven by horses or water wheels, and could maybe manage 20 to 30 feet of lift under ideal conditions. You'd need pumps generating tens of thousands of horsepower to keep a deep riverbed construction site dry, which is several orders of magnitude beyond what existed. It's not even close. It's like showing up to move a mountain with a teaspoon and claiming you finished the job in 6 months. The workforce requirements are equally absurd. Even if you somehow solved the water removal problem, you'd need thousands of workers laboring for years to excavate, build, and finish these foundations. We're talking about moving millions of tons of material, cutting and fitting massive stone blocks with precision tolerating no error, installing those elaborate chamber systems and decorative elements we discussed earlier. This is a major industrial undertaking requiring extensive logistics, supply chains, worker housing, food provision, all the infrastructure needed to support a massive construction project. And here's the thing that makes engineers laugh and then cry. There's virtually no documentation of any of this happening. No construction contracts, no payment records, no supply invoices, no worker accommodation arrangements, nothing. It's like these structures materialized out of thin air, which would be impressive except that bridges generally don't work that way. The historical archives are suspiciously quiet about what should have been the largest construction projects of their respective eras. You'd expect to find extensive records. These aren't minor undertakings, they're major public works that would consume significant portions of national budgets and labor forces. There should be correspondence between officials, proposals and cost estimates, records of materials purchased and transported. Medieval and early modern governments were actually quite good at documentation, especially when it came to expensive projects that needed royal approval and funding. Yet when you look for records of building these specific foundations at these specific depths, you find basically nothing beyond, "Bridge exists here now." The documentation gap is so conspicuous that it's almost funny, except it's not funny at all, because it suggests someone went to considerable effort to avoid documenting how these structures were really built. The only explanation that doesn't require believing in magic construction techniques is that these foundations weren't built underwater at all. They were built on dry land, at ground level, using perfectly reasonable construction methods available at the time. Then something catastrophic happened. The same something that appears on those map comparisons, that raised water levels, created or expanded rivers, and buried the lower portions of these structures under meters of sediment and flowing water. This would explain why the construction techniques make sense for ground-level building, but make zero sense for underwater work. It would explain the decorative elements that nobody would carve onto submerged structures. It would explain the lack of documentation about impossible pumping operations and underwater construction methods. Basically, it would explain everything except what official history is willing to admit happened. The caisson technology issue is particularly glaring. Pressurized caissons weren't successfully used for bridge construction until the mid-1800s. And even then, they were considered cutting-edge technology that required careful engineering and frequently resulted in workers getting decompression sickness. The idea that bridge builders in the 1600s or 1700s were casually deploying caisson technology advanced enough to work at 60-meter depths without any of the safety problems or engineering challenges that plagued 19th-century engineers is frankly ridiculous. It's like claiming that medieval carpenters were building skyscrapers but just forgot to mention it in any contemporary accounts. The technology gap is too large to hand-wave away with vague references to lost techniques or skills we don't understand anymore. Even if we generously assume that some super-advanced pumping system existed, there's still the problem of time. Building at those depths underwater would take exponentially longer than building at ground level because everything is harder, slower, and more dangerous. Workers can't breathe underwater, tools don't work as efficiently when submerged, materials are harder to move and position precisely. A project that might take 2 years on dry land would easily take 10 years underwater, possibly longer. Yet the historical timeline suggests these bridges were built remarkably quickly, which makes perfect sense if construction happened on dry land, and makes no sense whatsoever if it happened beneath a river. The temporal mathematics just don't work for underwater construction, no matter how generous you are with the estimates. There's also the small matter of worker safety, which admittedly wasn't a huge priority in historical construction, but still places practical limits on what's achievable. Working 60 meters underwater in the 1700s would result in catastrophic casualty rates. We're talking about people drowning on a regular basis, equipment failures causing mass fatalities, the whole disaster movie scenario. Projects with those kinds of death tolls generate documentation, inquests, complaints from families, records of replacement workers, something. The absence of any documentation about underwater construction disasters is telling. Either these projects had zero casualties, which would be miraculous, or they weren't happening underwater in the first place, which would be logical. The precision of the stonework presents another impossible challenge for underwater construction. Modern divers working with power tools struggle to achieve precision in underwater environments. The idea that 18th century masons using hand tools managed to cut, fit, and mortar massive stone blocks with credit card thin tolerances while working 50 meters underwater is beyond absurd. Water distorts vision, slows movement, makes precise measurement nearly impossible, and generally turns every task into a frustrating ordeal. You can't even use a measuring tape effectively underwater, let alone achieve the kind of precision we're seeing in these foundations. The only way to build with this level of accuracy is in a dry, controlled environment where you can actually see what you're doing and make fine adjustments. Like, say, on dry land before rivers flooded the valleys. Looking at the global distribution of these anomalies makes the pattern even clearer. This isn't isolated to one region or one river system. It shows up across Europe and North America with remarkable consistency. The same impossibly deep foundations, the same precision stonework, the same elaborate chambers, the same absence of construction documentation. Either there was a global conspiracy of bridge builders who all independently decided to waste enormous resources on underground structures using impossible technology, or we're looking at remnants of infrastructure built during a different geographical era. One of these explanations requires believing in coordinated insanity across multiple continents over several centuries. The other just requires accepting that geography changed more recently and more dramatically than we're told. I'll let you decide which seems more plausible. The chamber systems we discussed earlier make even less sense in an underwater construction scenario. Carving elaborate rooms and passages into bedrock while fighting against millions of gallons of water pressure isn't just difficult, it's pointless. Why would you invest that kind of effort into features that serve no structural function and will never be seen? Unless, again, they were built to be functional spaces when the structures existed above ground. The chamber designs show clear purpose: channels for directing flow, spaces for housing equipment, ventilation for air circulation. These are features you include when you're building an operational facility, not when you're just trying to anchor a bridge to bedrock while drowning. The architectural details are the final nail in the underwater construction coffin. Decorative carvings, ornamental moldings, precisely shaped architectural elements. None of this makes sense for work that's permanently submerged. It's an enormous waste of skilled labor and resources for zero aesthetic benefit, which would make these hypothetical underwater builders the most inefficient construction managers in history. Compare this to actual historical building practices, where decorative work was reserved for visible surfaces and structural elements were left plain. The presence of decoration on these deep foundations indicates they were meant to be seen, which means they were originally above water level. The logic is inescapable, unless you believe in construction projects run by people who really enjoyed pointless effort. So we're left with a situation where the maps don't show rivers that currently exist. The engineering required for underwater construction didn't exist when these were supposedly built. The documentation for massive construction projects mysteriously doesn't exist. And the structures themselves have features that only make sense for above-ground facilities. At some point, Occam's razor kicks in, and the simplest explanation becomes obvious. These weren't built underwater. The rivers came later, and something significant happened to change the landscape in ways that official history doesn't acknowledge. The question isn't whether this explanation is correct. The evidence is pretty overwhelming. The question is, what happened to flood these valleys, when it happened, and why there's such a coordinated effort to pretend it never occurred. And that's where things get really interesting, because if you're going to hide a geographical catastrophe, you need to control more than just the history books. You need to control the entire narrative about how rivers form, how construction works, and what was possible in different time periods. Which brings us to the next piece of this puzzle. Here's where this story goes from interesting local anomaly to, okay, what the actual hell is going on? Because these underwater structures aren't confined to one region or one river system, they show up everywhere. And I don't mean everywhere in a general sense. I mean everywhere with a precision and consistency that would make modern franchise operations jealous. We're talking about bridges spanning the Thames in London, the Rhine cutting through Germany, the Danube winding across Central Europe, and then jumping across the Atlantic to the Mississippi and Ohio rivers in North America. Different continents, different supposed builders, different historical contexts. Yet somehow these structures demonstrate architectural similarities that are frankly impossible to explain through coincidence or parallel development. The level of standardization is what really makes engineers uncomfortable at conferences when this topic comes up, which it doesn't, officially, because nobody wants to be the person asking awkward questions about infrastructure that shouldn't match. But the measurements don't lie. The underwater chambers beneath the Thames Bridge have nearly identical dimensions to chambers found under bridges crossing the Rhine. The canal systems carved into foundations in the Danube match the designs discovered in Mississippi River bridge supports. We're talking about mathematical proportions that repeat across thousands of miles, architectural motifs that show up in locations that supposedly had zero contact with each other, and technical solutions that demonstrate the same engineering. Principles applied consistently across multiple continents. This is like finding identical IKEA furniture in houses across the world before IKEA existed. Except, instead of flat-pack bookcases, it's massive stone infrastructure with precision-engineered energy system. The decorative elements are particularly revealing because architectural style is like a fingerprint. Every culture develops distinctive aesthetic preferences that make their work identifiable. Gothic is different from Byzantine, which is different from Romanesque, and so on. Yet the decorative carvings on these deep foundations show remarkable similarity regardless of location. The same geometric patterns, the same proportional relationships, the same technical execution. Either there was an incredibly efficient cultural exchange program that nobody documented, or these were all built by the same civilization using standardized designs. Given that we're talking about structures supposedly built by rival kingdoms, who were usually too busy fighting each other to coordinate on building codes, the single civilization explanation starts looking pretty compelling. It's almost like there was a unified infrastructure network spanning multiple continents, which would require the kind of organizational capacity and territorial control that official history insists didn't exist during the supposed construction. Period. Let's talk about the technical specifications, because they're where the standardization becomes impossible to dismiss as coincidence. The chamber depths average between 45 and 55 meters below current water level, with remarkably little variation. The channel angles for water flow consistently fall within a 5-degree range across different sites. The spacing between structural supports follows the same proportional ratios whether you're measuring in London or Ohio. This isn't approximate similarity. This is engineering standardization to a degree that requires centralized planning and shared technical knowledge. Modern construction achieves this level of consistency through detailed specifications, computer-aided design, and international building codes. Historical construction in supposedly fragmented kingdoms achieved it through what exactly? Telepathy? Really enthusiastic pen pals who just happen to all agree on precise engineering specifications? The explanation that doesn't require magical thinking is that there was a unified system, built by people who had access to sophisticated planning tools and coordinated implementation across vast territories. The architectural continuity across the Atlantic is particularly fascinating because it completely undermines the timeline we're given for transatlantic contact and cultural exchange. These bridge structures in North America demonstrate the same design principles and technical solutions as their European counterparts, which would require either extensive technical documentation sharing between continents or construction by the same civilization on both sides of the ocean. The official story about North American infrastructure development doesn't accommodate either possibility. We're supposed to believe that European settlers arrived with basically no advanced engineering knowledge, struggled to survive, and then somehow independently developed bridge construction techniques identical to those used in Europe, including all the impossible underwater work we discussed earlier. Or, much simpler explanation, the infrastructure was already there when they arrived, built by whoever controlled both continents before the supposedly revolutionary discovery of the Americas. The Mississippi River bridges are a perfect case study in how absurd the official narrative becomes when you actually examine the evidence. These are supposedly 19th century constructions built by frontier engineers working with limited resources in challenging conditions. Yet their underwater foundations match European specifications with remarkable precision, demonstrate the same chamber designs, include the same decorative elements that appear on structures supposedly built centuries earlier across an ocean. Either American engineers had access to incredibly detailed technical drawings from European bridge projects and decided to replicate them exactly for no apparent reason, or these were part of the same infrastructure network built during the same era, by the same civilization. One explanation requires believing in an elaborate transcontinental conspiracy of engineers who really enjoyed copying homework. The other just requires acknowledging that the builders had global reach. You decide which sounds more plausible. The Ohio River structures add another layer of weirdness because they're located in areas that were supposedly wilderness when European settlers arrived. There wasn't infrastructure. There wasn't developed civilization according to the standard historical narrative. Just pristine nature waiting to be conquered. Except there are these massive stone foundations with sophisticated energy systems buried under the riverbed, demonstrating construction capabilities that frontier settlements definitely didn't possess. It's like claiming you built a shopping mall in the middle of nowhere with no roads, no supply chains, and no workforce, and expecting people to just accept that as totally normal. The presence of standardized infrastructure in supposedly undeveloped territories suggests that the territory was already developed, just not by the people who later claimed credit for developing it. Now let's get into the really juicy part of this story. The engineer testimonies that didn't make it into official reports. When maintenance work required partial draining of river sections over the past decade, engineers got unprecedented access to these underwater structures. And what they found was apparently too weird for public consumption, which is saying something considering how much weird stuff does make it into public discourse. Several engineers who participated in these inspections have anonymously shared observations that paint a picture very different from the simple bridge foundations narrative that appears in official documentation. These accounts describe discoveries that sound more like industrial archaeology than standard infrastructure maintenance. Multiple witnesses independently reported finding metal mechanisms embedded in the stonework at depths of 30 to 40 meters below the surface. Not rusty bolts or simple iron reinforcement. Sophisticated mechanical devices that resembled turbines or generators, complete with rotating components and bearing systems. These weren't decorative flourishes or structural elements. These were functional machines, integrated into the stone construction, which raises some obvious questions about why bridge foundations would need turbine mechanisms. Unless, as we've been suggesting, these weren't bridge foundations at all, but energy generation facilities that later got rebranded as infrastructure support, after geography decided to rearrange itself. The descriptions of these mechanisms match across different locations and different inspection teams, which suggests either a coordinated hallucination or actual physical discoveries that someone really doesn't want widely discussed. The copper wire findings are even more intriguing because copper wire is traditionally associated with electrical systems, and electrical systems are not traditionally associated with 18th century bridge construction. Yet multiple engineers reported discovering copper conductors laid inside stone blocks, running through the structures in patterns that don't match any structural or decorative purpose. These weren't random copper deposits or corrosion. They were deliberately placed wires with insulation layers preserved by the stone, suggesting they were intended to carry current. Some accounts describe wire networks connecting the deep chambers to surface structures, almost like someone was planning to distribute power from generation points to utilization points. You know, standard bridge stuff. Totally normal reason to run electrical wiring through supposedly pre-electrical infrastructure. Nothing suspicious about finding copper distribution networks in structures that predate Edison's power plants by a century or more. The resonance chambers are probably the most fascinating discovery because they suggest sophisticated understanding of acoustic or electromagnetic properties. Engineers described finding spaces carved with unusual geometries, not the standard rectangular or arched chambers you'd expect for structural purposes, but complex shapes with specific angular relationships and surface treatments. These chambers apparently created measurable resonance effects when water flowed through them, almost as if they were designed to amplify or modulate some kind of energy transmission. It's the kind of feature you'd include if you were building a facility meant to generate and distribute power, not if you were just anchoring a bridge. The acoustic properties alone suggest knowledge of wave dynamics that wouldn't be formally understood until modern physics, which either means our historical timeline is off, or these builders were working from a completely different knowledge base than what we attribute to their era. The really telling part of these engineer testimonies isn't just what they describe, it's what happened after they started describing it. Once details began leaking to press outlets and online forums, access to these inspection sites was immediately and comprehensively shut down. Not temporarily closed for safety reasons, with plans to reopen. Completely locked down with permanent restricted access, armed security in some cases, and absolute prohibition on photography or documentation. The official explanation was protecting critical infrastructure from potential terrorist threats, which is the go-to excuse for anything you don't want people looking at too closely. Because apparently terrorists are really interested in medieval bridge foundations and might somehow weaponize knowledge about underwater chambers that have existed for centuries without causing any security concerns whatsoever. The logic is impeccable. Photographs and videos taken during the inspections were confiscated under classification orders. Engineers who participated were required to sign retroactive non-disclosure agreements with severe penalties for violations. Technical reports were redacted or simply vanished from archives. It's the kind of aggressive information control you'd expect from military secrets or proprietary technology, applied to infrastructure that's supposedly just old bridges built with conventional methods. The disproportion between the official "nothing to see here" narrative and the intensity of the suppression efforts is remarkable. If these really were just standard foundations, why the lockdown? Why the NDAs? Why confiscate documentation of historical construction techniques? The obvious answer is that what engineers found challenges fundamental assumptions about technological development and historical timelines, and certain institutions prefer those assumptions remain unchallenged. The pattern of suppression is consistent across multiple countries and multiple inspection sites, which suggests coordination at a level above individual governments or agencies. When bridge maintenance in Germany, England, and the United States all results in the same security lockdowns and documentation seizures, you're looking at either remarkable coincidence or centralized decision-making about what information should and shouldn't reach public awareness. The cynical interpretation is that there's institutional interest in maintaining the current historical narrative, regardless of physical evidence, because admitting that advanced infrastructure existed before it supposedly could have existed would require rewriting significant portions of accepted history. And rewriting history is complicated, expensive, and makes institutions look bad for getting it wrong in the first place. The engineer accounts that did manage to leak before the lockdowns went into full effect describe a consistent picture across different locations. Sophisticated mechanical systems, electrical distribution networks, resonance chambers designed for energy manipulation, all integrated into structures supposedly built for the simple purpose of holding up roads over rivers. The testimonies are specific, technical, and corroborated by multiple independent observers. These aren't vague claims or blurry photographs. They're detailed engineering observations from professionals who understand construction and can recognize when something doesn't fit expected parameters. The fact that these testimonies had to be shared anonymously, after NDAs and classification orders, suggests they're describing something that official channels want to keep quiet. What makes this suppression particularly frustrating is that the physical evidence is still down there. The chambers exist, the mechanisms exist, the copper networks exist. They're not going anywhere just because access is restricted. Future inspections, assuming anyone is ever allowed to conduct them, will find the same anomalies. The truth doesn't change just because it's inconvenient for current narrative. All the lockdowns accomplish is preventing public discourse and independent analysis, which is probably the point. As long as information is controlled, the official story can be maintained regardless of what physical reality actually demonstrates. It's a strategy that works reasonably well until enough people start asking why such aggressive measures are necessary to protect historical bridge foundations from scrutiny. The global coordination of these suppression efforts is almost as revealing as the structures themselves. When multiple nations simultaneously classify information about underwater infrastructure, implement identical security protocols, and enforce comparable documentation seizures, you're witnessing a level of international cooperation that supposedly doesn't exist except for major security threats. Apparently, old bridge foundations qualify as such a threat, which raises interesting questions about what those foundations actually represent. The most straightforward explanation is that they're evidence of capabilities and systems that don't fit the technological timeline we're taught. And admitting that would require acknowledging that our understanding of historical development is fundamentally flawed. Better to lock it all down and pretend the inconvenient evidence doesn't exist, which works until it doesn't. So we have a global network of standardized infrastructure demonstrating impossible construction techniques, built by an unknown civilization with apparent continental reach, containing energy generation and distribution systems that shouldn't exist for their supposed time period. And when modern engineers get close enough to document the actual physical evidence, the whole operation gets shut down and classified. The pattern is clear enough that even the most skeptical observer has to acknowledge something weird is happening. Either there's a massive coincidence involving independent bridge builders across multiple continents and centuries, all happening to build identical energy systems nobody admits existed, or we're looking at remnants of a unified civilization that somebody really doesn't want us to recognize. The evidence strongly suggests the latter, which means the next question is, what happened to that civilization? And why is there such institutional investment in pretending it never existed? And that's exactly where we're headed next. So after all this evidence of impossible construction, suppressed testimonies, and global infrastructure networks, you might be wondering, okay, but how did these things actually work? What were they designed to do? Well, fortunately for us, and unfortunately for people invested in maintaining official narratives, independent researchers have taken it upon themselves to figure that out. Using whatever photographs and technical diagrams managed to escape classification, along with some creative engineering analysis, they've reconstructed a pretty compelling picture of what these underwater structures were actually designed to accomplish. And spoiler alert, it's not hold-up bridges. It's generating electricity on a scale that would make modern utility companies nervous. The reconstruction work started with a simple question that official reports conspicuously avoided asking. Why would you design chambers and channels with these specific geometries if all you needed was structural support? Because the answer, once you actually look at the fluid dynamics involved, is obvious to anyone with engineering training. These chambers weren't random spaces. They were carefully calculated systems designed to capture and utilize water flow for power generation. The channels carved into stone foundations show precise angles optimized for directing water pressure. The chamber dimensions create pressure differentials that would drive rotational motion. The whole setup functions as what we'd now call a run-of-river hydroelectric system, except it was allegedly built before anyone officially understood how to convert water flow into electricity. Which is sort of like finding a working iPhone in a Roman ruin and being told it's just decorative pottery. Let's break down how this would actually work, because the engineering is honestly elegant in its simplicity. Major rivers carry enormous volumes of water moving at significant velocity, which represents tremendous kinetic energy just flowing past these structures every second. A properly designed system would redirect a portion of that flow through strategically placed channels, not enough to obstruct the river or cause flooding, just enough to capture useful energy. Those channels would direct water through chambers housing mechanical components, probably something resembling water wheels or primitive turbines. The flowing water would spin these mechanisms, converting kinetic energy into rotational mechanical energy. From there, it's a relatively straightforward step to generate electricity using copper coils and magnets, which is basically how generators work today. The presence of copper elements integrated into these structures suddenly makes perfect sense if you're building power generation facilities. It makes zero sense if you're just building bridge foundations, unless your construction budget included a line item for unnecessary expensive metal for no reason. The blade or wheel systems would have been hidden inside those sealed chambers, discussed earlier, protected from damage and positioned to maximize efficiency. Water enters through intake channels, passes through the generation chamber where it spins the mechanical components, then exits through outflow channels back into the river. The entire process happens continuously as long as water is flowing, which in major rivers means basically all the time. It's passive power generation. No fuel required, no complex maintenance, just physics doing its thing using natural river current. The beauty of this design is that it's sustainable and distributed. You're not building one massive dam that disrupts the entire ecosystem. You're placing multiple smaller generation points along the river, each contributing to a network that collectively produces substantial power. It's actually more sophisticated than modern hydroelectric approaches that tend toward brute force solutions involving giant concrete barriers. The isolated chambers that engineers reported finding are particularly interesting because they suggest energy storage capacity, which is always the challenge with renewable generation. You need somewhere to accumulate power during periods of excess production, so you can use it during periods of higher demand. These chambers, with their sealed construction and careful positioning, could potentially serve as primitive batteries or capacitors, storing charge until needed. The copper networks connecting them would allow distribution of that stored energy to wherever it was required. We're talking about a complete power grid, generation, storage, and distribution, all integrated into what we've been calling bridge foundations. The technical sophistication required to design such a system is considerable, which makes its official non-existence even more absurd. Now let's talk about the mathematics, because numbers have this annoying habit of being objective and not caring about narrative convenience. When you calculate the theoretical power output of these systems based on river flow rates, water velocity, and the dimensions of the discovered chambers, the results are frankly stunning. A major river like the Thames or the Rhine moves millions of liters of water per second through its channel. Even capturing a small fraction of that flow through optimally designed turbines would generate megawatts of electricity. And we're not talking about one isolated generator. We're talking about networks of these structures spaced along the rivers at strategic intervals. The cumulative output of such a distributed system would rival modern hydroelectric dams, with the added benefit of not requiring massive construction that alters river ecosystems. Let's run some back-of-envelope calculations here because I enjoy making power companies uncomfortable. The Thames at London moves approximately 65 cubic meters of water per second during normal flow. That's 65,000 liters, or about 65 tons of water passing by every single second. Even if you're only capturing 10% of that flow through your generation system, you're working with 6,500 liters per second, which is substantial volume. Water flowing at typical river velocities carries kinetic energy that can be converted to electricity with efficiency rates around 80 to 90% for well-designed turbines. Conservative estimates suggest a single bridge location on the Thames could generate 5 to 10 megawatts continuously. Now multiply that by the number of bridges spanning the river, and you're looking at distributed power production that could easily supply significant portions of a city's electricity needs. And that's just one river in one city. Scale this up across Europe and North America with all the major rivers hosting these standardized structures, and you're talking about an energy network producing hundreds of megawatts collectively. The Rhine alone, with its higher flow rates, could potentially generate more power through this distributed system than many modern power plants. The Mississippi, which is basically a liquid highway carrying phenomenal water volumes, could theoretically produce enough electricity through strategic turbine placement to power entire regions. The infrastructure was already there, built into foundations we thought were just supporting roads. All it needed was the mechanical components to convert that constant river flow into usable electricity. And based on engineer testimonies, those components existed too, until somebody decided they'd be better off classified and forgotten. This brings us to a fascinating historical puzzle that suddenly makes sense in light of these calculations. 19th century buildings with electrical lighting and devices that official history struggles to explain. We've all seen photographs of grand buildings from the 1800s with elaborate electrical lighting systems, powered devices, and technological amenities that supposedly shouldn't exist because commercial electricity wasn't widely available. The standard explanation is either they used gas lighting, which doesn't match the documented electrical systems, or they had small private generators, which doesn't explain the scale of power distribution evident in period accounts. But if there was already a functional power grid built into urban infrastructure, drawing energy from river-based generators that have been conveniently redefined as bridge foundations, suddenly those electrical systems have a perfectly logical power source. The architectural evidence supports this theory quite nicely. Many 19th century buildings, particularly those near rivers or former river courses, have electrical infrastructure integrated into their original construction, not added later as official timelines suggest. We're talking about wiring conduits built into walls, distribution panels positioned for optimal layout, connection points that suggest planning for electrical service from the start. The conventional explanation is that builders were incredibly forward-thinking and pre-wired buildings for electricity that wouldn't be available for decades, which seems unlikely given that construction budgets are always tight and nobody installs expensive infrastructure for purely hypothetical future services. The alternative explanation is that electricity was available, supplied by river generators, and buildings were wired accordingly because having power was useful. Radical concept, I know. There's also the matter of street lighting in major cities during periods when official history insists electrical infrastructure didn't exist. Contemporary accounts describe streets illuminated by arc lights and electrical lamps in the 1870s and 1880s, powered by mysterious sources that historians vaguely attribute to experimental systems or private power stations that conveniently left no records. But if you've got river-based generators producing megawatts of electricity through a distribution network we've been calling bridge foundations, you don't need mysterious private stations. You've got a citywide power system that's literally built into the infrastructure, hiding in plain sight under the convenient label of structural supports. The lights work because there's actual electricity being generated and distributed, not because of some temporary experimental setup that nobody documented. The distribution mathematics work out surprisingly well too. Copper wiring can transmit significant power over distances measured in kilometers before losses become prohibitive. The spacing between bridge structures on major rivers falls within optimal distribution ranges, suggesting deliberate planning for power network coverage. You could theoretically draw power from multiple generation points along a river, distribute it through the copper networks integrated into the structures, and supply electricity to surrounding districts with reasonable efficiency. It's not as sophisticated as modern grid systems with transformers and voltage regulation, but it doesn't need to be. For powering lighting systems, motors, and other 19th century electrical applications, a relatively simple distributed network would suffice. The fact that such a system leaves minimal documentary evidence makes sense if it was simply considered normal infrastructure, the equivalent of how we don't write extensive treatises about how water pipes work because they're just part of the built environment. The resonance chambers that engineers reported add another fascinating dimension to this power system. If these chambers were designed with specific acoustic or electromagnetic properties, they could potentially amplify or modulate electrical generation. Resonance effects can significantly boost energy capture from flowing water, and certain chamber geometries could create standing wave patterns that enhance turbine efficiency. This suggests a level of understanding about wave dynamics and energy manipulation that's supposedly advanced for the supposed construction era, which is becoming a recurring theme in this story. Either the builders were randomly creating chambers that happened to have perfect resonance properties by incredible coincidence, or they actually understood the physics involved and designed accordingly. Given the consistency of chamber designs across multiple locations, intentional engineering seems way more likely than cosmic luck. Independent researchers who've attempted to replicate these designs using modern materials report surprising success. Small-scale models built according to the chamber dimensions and channel angles discovered in underwater structures demonstrate efficient power generation, even with minimal water flow. Scale these models up to the actual size of the bridge foundations and the full river volumes involved, and the energy output matches the theoretical calculations. These aren't just interesting ideas. They're proven engineering concepts that work when you actually test them. The fact that nobody is commercially developing this technology despite its obvious potential for clean, renewable energy is telling. Either every energy company in the world independently decided that free river power is not worth pursuing, or there's institutional resistance to acknowledging that these systems existed first and work better than expected. The sustainability implications are actually remarkable if you think about it. These systems generate continuous power without fossil fuels, without greenhouse emissions, without radioactive waste, without massive environmental disruption from dam construction. They use natural river flow that's going to happen anyway, and convert a portion of that energy to electricity while leaving the ecosystem largely intact. It's the kind of green energy solution that modern civilization supposedly struggled to develop, except it was apparently figured out centuries ago and then abandoned or suppressed for reasons that make zero sense from a technological or economic standpoint. Unless, of course, admitting these systems existed would undermine both the historical timeline and the business models of industries that profit from complex, centralized power generation. The network topology is what really suggests this was planned as a comprehensive system rather than isolated experiments. The spacing of bridge structures along major rivers shows mathematical relationships. They're not randomly placed, but positioned at intervals that optimize coverage while minimizing transmission losses. It's grid planning, just implemented in stone and copper instead of steel towers and aluminum wire. Someone clearly understood not just how to generate power at individual points, but how to create an integrated network that functioned as a coordinated system. This requires fairly sophisticated knowledge of electrical engineering, load distribution, and network design. The kind of knowledge that supposedly didn't exist until the late 1800s, but somehow got applied to infrastructure built earlier. The timeline contradictions just keep piling up. What makes this reconstruction especially convincing is how many disparate observations suddenly make sense when viewed through this lens. The impossible underwater construction becomes logical. It wasn't underwater when built. The decorative elements become functional. They were meant to be seen when structures were above ground. The copper networks become obvious. They're distributing generated electricity. The suppressed engineer testimonies become threatening. They're documenting a system that shouldn't exist. The aggressive classification becomes necessary. Acknowledging this changes everything about historical technological development. All the pieces fit together when you accept that these weren't bridge foundations at all, but power generation facilities that got flooded and repurposed, with their original function conveniently forgotten or deliberately obscured. The really frustrating part is that this technology is still viable. If we actually excavated these structures, restored the mechanical components, and integrated them into modern power grids, they could be generating clean electricity right now. Instead, they're sitting underwater, classified as historical curiosities, while we debate building new nuclear plants and argue about renewable energy targets. It's like discovering your house has a fully functional solar power system built into the roof that nobody told you about, so you keep paying electric bills while free energy goes unused. The absurdity would be funny if it weren't so wasteful. But acknowledging these systems means acknowledging that official history is wrong about technological development, which apparently is more problematic than continuing to use inferior energy solutions. So there you have it, a complete reconstruction of how these underwater structures actually worked, supported by both engineering analysis and mathematical calculations that demonstrate substantial power generation capacity. The evidence suggests a sophisticated distributed energy network built into infrastructure we've been calling bridges, generating electricity from river flow in a sustainable and efficient manner. The technology was sound, the implementation was impressive, and the results would have provided substantial power to cities that officially weren't supposed to have electricity yet. The only question remaining is what happened to this system, why it got buried both literally and figuratively, and why institutions are so invested in pretending it never existed. And that's exactly where this story gets really interesting. So we've established that these underwater structures exist. They demonstrate impossible engineering. They could generate substantial electricity, and they're part of a global network that official history pretends never happened. Now let's talk about what happens when people start noticing all of this publicly, and institutions realize they have a narrative control problem. Because once the first reports about deep underwater anomalies started appearing in technical journals and online forums, something fascinating happened. Multiple governments simultaneously decided that bridge foundations suddenly qualified as critical security infrastructure requiring immediate classification. The timing was remarkable. It's almost like someone sent out a memo saying, "Hey, people are asking uncomfortable questions about our bridges. Time to lock everything down." The official explanation rolled out with impressive coordination across different countries. Protection against terrorist threats. Because apparently terrorists have been just waiting for someone to publish details about medieval bridge construction so they could finally implement their master plan to what exactly? Weaponize knowledge about underwater chambers that have existed for centuries without causing any security problems? The logic is spectacularly thin. It's like deciding that publishing historical information about Roman aqueducts is a national security risk because terrorists might learn about water distribution, which is definitely a thing that keeps security agencies awake at night. The explanation works fine if you don't think about it for more than 5 seconds, which seems to be the target audience for these kinds of official statements. What makes the classification efforts particularly transparent is their selectivity. Not every bridge got the security treatment, just the ones demonstrating the most elaborate underwater structures, the deepest foundations, the most sophisticated chamber system. The bridges with relatively simple supports and conventional construction? Those are fine. Apparently terrorists aren't interested in normal infrastructure. But the ones with multi-level chambers, integrated copper networks, and precision stonework that predates the technology needed to build them, those get immediate lockdowns, armed guards, and no photography zones extending hundreds of meters in every direction. It's almost like the security concern isn't terrorism at all, but rather preventing documentation of structures that challenge fundamental historical assumptions. Wild theory, I know, but the evidence is pretty compelling. The documentation purge was thorough and systematic. Technical reports that mentioned unusual underwater features suddenly became classified or simply vanished from accessible archives. Photographs taken during inspection work were confiscated with retroactive classification orders that somehow made historical construction details a state secret. Video footage captured by maintenance crews got seized under national security provisions that were clearly never intended to apply to bridge foundations, but apparently are flexible enough to cover anything authorities want to keep quiet. The legal gymnastics required to classify information about centuries-old stone structures as contemporary security threats is honestly impressive. It's the bureaucratic equivalent of claiming your grandmother's cookie recipe as classified military intelligence. Engineers who participated in the inspection work found themselves signing non-disclosure agreements that hadn't existed when they started their jobs. These NDAs came with aggressive penalties for violation. Not just termination, but potential criminal prosecution and massive financial damages. For talking about bridge foundations, the disproportion is remarkable. You can discuss nuclear power plant designs with more freedom than you can discuss underwater chambers and river structures, which tells you everything you need to know about which topic makes institutions more nervous. The message was clear. Whatever you saw down there, you didn't see it. And if you did see it, you're legally forbidden from mentioning it ever again. Very normal approach to managing information about historical infrastructure that supposedly has no contemporary relevance. The physical cover-up in some cases was even more direct. Sites that had been partially drained for inspection were deliberately reflooded ahead of schedule, often before planned documentation could be completed. Some locations were filled with concrete, ostensibly for structural reinforcement, but conveniently obliterating any evidence of the elaborate chambers and mechanical systems that engineers had reported. It's remarkably thorough for maintenance work that's supposedly just about keeping bridges functional. Most infrastructure projects struggle to get adequate funding and move at glacial pace. But when it comes to burying evidence of anomalous construction, suddenly resources appear and work happens with impressive speed. The priorities are illuminating. The international coordination of these classification efforts is what really makes the pattern obvious. When Germany, England, France, and the United States simultaneously implement identical security protocols around bridge infrastructure within months of each other, you're not seeing independent policy decisions. You're seeing coordinated institutional response to a shared problem. Countries that can barely agree on trade policies or diplomatic protocol somehow achieved perfect synchronization on classifying underwater bridge structures. Either this is the most unlikely coincidence in policy history, or there's communication happening at levels above national governments about what information should and shouldn't reach public awareness. The simplest explanation is that institutions recognized a threat to historical narratives and coordinated a response to contain it. What's particularly suspicious is which bridges got the most aggressive treatment. The structures with the deepest foundations, the most elaborate chamber systems, the clearest signs of integrated energy generation capabilities. Those are the ones that got locked down hardest and fastest. Meanwhile, bridges with conventional construction remained accessible for standard maintenance and documentation. It's almost like someone identified which sites posed the greatest challenge to official historical timelines and prioritized suppressing information about those specific locations. If the security concern were actually terrorism, the response would be universal. All bridges would be restricted, or none would be. The selective lockdown reveals that the concern isn't external threats, but rather internal information management. The legal framework used to justify these classifications is creative in ways that should concern anyone who values transparency. National security provisions intended for military secrets and intelligence operations got repurposed to cover historical construction details. Critical infrastructure protection laws, meant to prevent sabotage of power grids and water systems, got applied to centuries-old stone foundations. Anti-terrorism legislation designed to prevent coordination of attacks got used to suppress discussion of architectural features. It's legal authority creep on a massive scale. And it's happening because existing frameworks don't actually have provisions for hiding evidence that contradicts historical narratives, so authorities had to improvise with whatever legal tools were available. The result is a bizarre situation where talking about bridge construction can theoretically get you prosecuted under the same laws used against people planning actual attacks. Now, despite this comprehensive effort to bury information both literally and figuratively, some people decided they weren't interested in pretending these discoveries didn't happen. Independent engineers, amateur inventors, and general enthusiasts of technologies that shouldn't exist according to official timelines have been working to reconstruct and replicate the hydraulic generation systems based on whatever documentation escaped classification. And here's where the story gets interesting in a different way. Because their experiments are working. Not hypothetically, not in theory, but in actual practice with measurable results. Turns out, when you build systems according to the chamber dimensions and channel angles documented in those underwater structures, they generate electricity quite efficiently. Who knew? Well, apparently whoever designed the originals knew, but we're supposed to have forgotten that. These modern reconstruction efforts started small. Engineers building scale models in university labs or backyard workshops, testing whether the theoretical designs would actually function. The results were immediately promising. Simple hydraulic systems based on the discovered chamber geometries demonstrated power generation capabilities that matched or exceeded expectations from theoretical calculations. This wasn't cutting-edge technology requiring rare materials or specialized manufacturing. This was straightforward mechanical engineering using principles that have been understood for centuries. Water flows through carefully angled channels, spins a turbine or wheel mechanism, generates rotational energy that gets converted to electricity. The simplicity is almost offensive considering how much official resistance there is to acknowledging these systems existed and worked. Some experimenters have gone beyond laboratory testing and built functional prototypes integrated into small-scale water systems. These aren't full-sized river installations, obviously. You can't exactly start drilling into classified bridge foundations without attracting unwanted attention from authorities who've made their position on this topic very clear. But working with streams, canals, and other accessible water flows, independent developers have demonstrated that neo-Tartarian generators, as they're sometimes called with varying degrees of irony, can produce usable electricity continuously with minimal maintenance. The power output scales predictably with water volume and velocity, which means the calculations suggesting full-sized river installations could generate megawatts aren't just theoretical speculation. They're conservative estimates based on proven performance. The potential applications are honestly exciting if you're into renewable energy or just appreciate technology that works efficiently without requiring complex supply chains and massive infrastructure investments. Imagine integrating these generation systems into existing bridge foundations, tapping into river flow that's already happening to produce clean electricity for surrounding communities. No fuel costs, no emissions, no radioactive waste. Minimal environmental impact since you're working with existing structures and natural water movement. It's distributed generation at its finest. Every bridge becomes a small power plant contributing to the grid. The cumulative output from a city's bridges could potentially supply significant portions of local electricity needs, reducing dependence on centralized power plants and all the infrastructure required to support them. Several enthusiastic engineers have even developed detailed proposals for retrofitting existing bridges with modern versions of these hydraulic generators. The designs are remarkably practical. You wouldn't need to fundamentally alter bridge structures, just integrate generation equipment into spaces that already exist beneath the waterline. Modern materials and manufacturing techniques could make these systems even more efficient than the originals, potentially achieving power generation densities that would make renewable energy advocates very happy. The proposals include everything from technical specifications to cost-benefit analyses, showing that installation expenses would be recovered through power generation within a few years. It's genuinely useful technology that addresses real energy challenges using proven engineering principles. So naturally, it faces absolutely fierce resistance from every institutional authority with any say in infrastructure policy. Energy corporations hate these proposals for reasons that are transparently self-interested and honestly kind of refreshing in their lack of pretense. Distributed generation systems that anyone could install and maintain threaten business models built on centralized power production and distribution monopolies. If cities can generate substantial electricity from their bridges using river flow that's free and continuous, that's power not being purchased from utility companies. The economics are troubling if you're in the business of selling electricity, and the fact that this technology could be implemented fairly cheaply using existing infrastructure makes it even more threatening. There's no massive capital requirement that creates natural barriers to entry, no complex technology that requires specialized knowledge, just hydraulics and some basic electrical engineering. The simplicity is the problem from an industry perspective. Government resistance is more complex but equally vigorous. Energy policy in most countries is deeply intertwined with economic planning, international relations, and, let's be honest, lobbying from incumbent power producers who prefer the status quo. Proposals to fundamentally change how electricity gets generated tend to face bureaucratic obstacles even when they're sensible, and proposals that also implicitly validate historical claims about advanced pre-modern technology face obstacles that are practically insurmountable. Permitting requirements become Byzantine, safety reviews drag on indefinitely, environmental impact assessments demand unreasonable levels of detail. Every regulatory tool available gets deployed to delay or prevent implementation, not because the technology is unsafe or environmentally harmful, but because accepting it requires acknowledging things about history and infrastructure that institutions would prefer remained unacknowledged. Some developers have tried working within the system, submitting proper applications and following all bureaucratic procedures, hoping that the technical merits would eventually overcome institutional resistance. These efforts generally end in frustration after years of regulatory limbo and increasingly arbitrary requirements that seem designed to make the projects impossible rather than safe. It's the administrative equivalent of being told you can have dessert after dinner, but dinner keeps getting delayed indefinitely for reasons that don't quite make sense. Other developers have taken more guerrilla approaches, building small unofficial installations and demonstrating functionality as proof of concept, figuring that working examples are harder to ignore than theoretical proposals. These efforts tend to attract official attention of the unwelcome kind, resulting in shutdown orders and threats of prosecution for unauthorized modification of infrastructure. The legal environment around this technology is fascinatingly hostile. Even though the underlying principles are well-established engineering, and the installations wouldn't violate any reasonable safety or environmental standards, authorities consistently find regulatory frameworks to prohibit implementation. Unauthorized power generation, modification of public infrastructure, environmental impact on waterways, electrical safety compliance. There's always some legal hook that can be used to shut projects down. The creativity authorities demonstrate in finding applicable regulations is impressive, especially compared to their usual approach to enforcement where violations of actual important safety standards frequently get overlooked due to resource constraints. Apparently, when it comes to preventing deployment of bridge-based hydraulic generators, suddenly enforcement resources are abundant. What's particularly frustrating for developers is watching their proposals get rejected, while objectively worse energy solutions get approved and subsidized. Coal plants that generate enormous pollution receive permits and tax breaks. Nuclear facilities with waste disposal problems nobody's solved get built with government support. Expensive solar farms requiring massive land use get encouraged through incentive programs. But suggest installing hydraulic generators in existing bridge structures to capture energy from water that's flowing anyway. And suddenly regulators are very concerned about potential impacts and risks. The selective application of caution is so transparent it's almost funny, except it's blocking deployment of useful technology that could actually help address energy challenges sustainably. Some independent developers have started looking at international opportunities, figuring that perhaps countries less invested in maintaining particular historical narratives or protecting incumbent energy industries might be more receptive. Results have been mixed. A few installations have been built in locations where regulatory environments are more flexible, or authorities are less concerned about the implications of acknowledging effective pre-modern engineering. These working examples demonstrate that the technology scales well and performs as predicted, generating clean power continuously with minimal maintenance requirements. But broader adoption remains limited by the same institutional resistance that exists in Western countries, suggesting the opposition isn't just local policy preference, but reflects deeper international consensus about maintaining certain narratives, regardless of technical evidence. The irony of this situation is almost painful if you think about it for too long. Modern civilization desperately needs sustainable energy solutions. Climate change is a genuine concern. Fossil fuel dependence creates geopolitical vulnerabilities, existing renewable technologies have limitations in terms of intermittency and resource requirements. Here's a proven approach to generating clean electricity using infrastructure that already exists and natural water flow that's continuous and free, with minimal environmental impact and reasonable implementation costs. It addresses multiple major challenges simultaneously, using straightforward engineering that's been validated through both historical evidence and modern testing. And institutions are actively suppressing it, not because it doesn't work, but because acknowledging that it works requires admitting things about history that challenge official narratives. The priorities are absolutely backward, but they're consistently backward, which at least demonstrates commitment to maintaining narrative control even at significant practical cost. The developer community working on these systems has developed a somewhat darkly humorous culture around the obstacles they face. There are online forums where people share stories of regulatory rejections that make no technical sense, compile lists of contradictory requirements from different agencies, and document instances of working installations that had to be dismantled, for reasons officials couldn't coherently explain. It's gallows humor born from watching useful technology get blocked by institutions more concerned with controlling information than solving problems. But the community persists, continuously refining designs, conducting experiments, and building evidence that this technology works regardless of how much authorities would prefer it didn't. Eventually, the thinking goes, the practical advantages will overcome institutional resistance, or at least enough working examples will exist that suppressing the technology becomes impossible. Whether that optimism is justified remains to be seen. The historical pattern suggests institutions are pretty good at maintaining narratives even in the face of contradictory evidence, especially when they have legal tools and economic leverage to discourage dissent. But the technology is sound, the need is genuine, and information is considerably harder to suppress in the internet age than it was in previous eras. Something will eventually give, either institutional resistance or developer persistence. Until then, we have the absurd situation of bridges sitting on power generation infrastructure that could be supplying clean electricity to cities, while those same cities debate how to meet renewable energy targets and reduce carbon emissions. The solutions are literally built into existing infrastructure, proven to work both historically and in modern testing, and utterly unavailable due to institutional determination to avoid acknowledging certain historical realities. It's not exactly an inspiring example of how modern civilization handles technological innovation or historical evidence, but it is remarkably consistent with how institutions respond when facts threaten convenient narratives. Now here's where we need to zoom out and look at the bigger picture, because these hydraulic generators under bridges aren't operating in isolation. They're one component of what appears to be a comprehensive, multi-layered energy system that makes modern power grids look primitive by comparison. And this is where the Tartarian connection becomes impossible to ignore. Because when you start examining other architectural features from the same era with the same critical eye we've been applying to bridges, you discover a pattern that's frankly staggering in its sophistication. The water generators were just the foundation layer, literally, of an integrated network that pulled power from multiple sources simultaneously. It's like discovering your house has solar panels, wind turbines, and geothermal all working together. Except you thought you just had regular electricity, and nobody mentioned the elaborate renewable setup. Let's talk about those building domes that define so much historical architecture, the ones with ornate metalwork and unusual shapes that architecture historians describe as decorative or symbolic. Decorative is a great word to use when you can't. Explain why every major building from a particular era has similar dome structures with identical proportional relationships and curious metal fittings. Look closely at these domes, and you'll notice they're not solid decorative caps. They're engineered structures with internal chambers, ventilation systems, and metal components that serve no obvious architectural purpose. Unless, of course, they're atmospheric energy collectors, designed to capture electrical potential from the air and channel it into the building systems. Which sounds wild until you remember that atmospheric electricity is real, measurable, and was being actively studied in the 18th and 19th centuries by people who understood it could be harnessed. The domes aren't decoration. They're technology disguised as architecture. The metalwork on these domes is particularly revealing once you know what to look for. Those elaborate finials and decorative metal elements aren't random artistic flourishes. They're conductors positioned to maximize atmospheric electrical collection. The shapes and materials match what you'd design if you were trying to capture charge from the air and direct it downward into a building's distribution system. It's the same principle as a lightning rod, except instead of protecting the building from electrical strikes, These systems were designed to continuously harvest ambient atmospheric charge. The fact that this all looks decorative is brilliant engineering disguised through aesthetic design. Nobody questions ornamental metalwork on historic buildings, so it's the perfect camouflage for functional electrical infrastructure. Then there are the cathedral spires and towers that dominate city skylines across Europe and North America. Official architectural history explains these as expressions of religious devotion, attempts to reach toward heaven, statements about the glory of God and the power of the Church. All of which is very nice symbolically, but completely fails to explain the technical specifications these structures demonstrate. Many spires are topped with metal crosses or other conductive elements positioned at precisely calculated heights. They're grounded through the building structure using metal cables or rods that run through the interior. Some have chambers and platforms at specific elevations that serve no apparent religious or architectural function. This all makes perfect sense if you're building etheric energy antennas, structures designed to interact with electromagnetic fields and channel that energy for practical use. It makes considerably less sense if your only goal is architectural grandeur and spiritual symbolism. The positioning of these spires is another detail that stops looking coincidental once you map it out. They're not randomly distributed across cities. They're placed at specific intervals and elevations that suggest intentional network planning. The spacing creates overlapping coverage areas. The height variations optimize reception at different wavelengths. The geometric relationships between spire locations demonstrate mathematical precision. It's grid design, just implemented through buildings that everyone assumes are purely religious structures. The etheric energy these systems could theoretically capture and distribute would provide another layer to the overall power network, complementing the hydraulic generation from rivers and the atmospheric collection from domes. You're looking at a civilization that understood how to pull energy from multiple environmental sources simultaneously and integrate them into a unified distribution system. What makes this integrated network particularly impressive is how the different components would complement each other's limitations. Hydraulic generation from rivers provides consistent baseline power as long as water is flowing, which is most of the time. Atmospheric collection from building domes captures energy during storms and periods of high electrical activity. Etheric antennas disguised as spires harvest electromagnetic energy that varies with solar activity and atmospheric conditions. No single source is perfectly constant, but combined together they create a robust system with multiple redundancies. It's more sophisticated than modern grids that typically rely on one or two primary generation sources with backup systems. This was a civilization that apparently understood distributed renewable energy generation at a level we're still trying to achieve today, with all our advanced technology and engineering education. The integration points are visible if you look for them. Many historic buildings near rivers have architectural features that suggest connections between basement or foundation levels and higher structures. Not for structural reasons, but apparently for conducting power from the hydraulic generators up to the atmospheric systems in domes. Cable runs, conduit spaces, and metal elements link different parts of buildings in ways that make perfect sense for electrical distribution and make limited sense for pure architecture. The whole city infrastructure becomes an interconnected energy system when you view it through this lens, with rivers providing baseload, buildings collecting atmospheric charge, and spires capturing etheric energy, all feeding into a network that distributed power throughout urban centers. This explains so much about 19th century technology that official history struggles with. Cities had widespread electrical lighting decades before commercial power plants supposedly made it viable. Buildings featured electric elevators, climate control systems, and powered equipment that required substantial electricity without any documented power source. The standard historical explanation involves vague references to private generators and experimental systems that conveniently left no records, which is the academic equivalent of "a wizard did it" as a historical explanation. But if cities already had functioning power grids built into their infrastructure, pulling from rivers, atmosphere, and electromagnetic fields through systems we've rebranded as decorative architecture, then the electrical technology makes perfect sense. The infrastructure existed. We've just been trained not to recognize it as electrical systems. The technological level this represents is honestly staggering when you think about implications rather than just mechanics. This wasn't a civilization stumbling toward understanding of electricity through trial and error. This was a culture with sophisticated comprehension of multiple energy domains, advanced enough to design integrated systems that optimized different sources for complementary operation. They understood fluid dynamics well enough to build efficient hydraulic generators, They grasped atmospheric electricity sufficiently to design collection systems into building architecture. They had knowledge of electromagnetic fields and how to harvest energy from them using precisely designed antenna structures. And they implemented all of this not as isolated experiments, but as coordinated infrastructure deployed across entire continents. The organizational capacity, technical knowledge, and engineering capability required for this is extraordinary. It doesn't match anything we're told about pre-industrial or early industrial civilization. This is where the Tartarian connection becomes directly relevant, because we're not talking about technological developments that could have emerged from the fragmented kingdoms and emerging nation-states of 18th century Europe. We're talking about a unified system requiring centralized planning, shared technical knowledge, and coordinated implementation across vast territories. The standardization we discussed earlier in bridge construction extends to the other components. Domes show consistent designs across different cities. Spires follow similar proportional relationships regardless of location. The integration between systems demonstrates common engineering principles. This isn't convergent evolution, or different groups independently developed similar solutions. This is a single civilization with globe-spanning reach implementing a coherent technological system according to standardized specifications, which is exactly what Tartarian theories propose, an advanced predecessor culture that was subsequently erased from history and had its technological achievements reattributed to successor civilizations. The energy paradigm this represents is revolutionary in ways that would fundamentally disrupt modern economic and political structures, which starts to explain why evidence of these systems gets so aggressively suppressed. Imagine publicly acknowledging that cities could be powered through distributed renewable systems built into their existing architecture, requiring no fuel costs, no centralized power plants, minimal maintenance, and essentially no environmental impact. That acknowledgement would raise some uncomfortable questions about why modern civilization abandoned superior technology in favor of expensive, polluting, centralized generation that requires massive infrastructure investments and creates dependency on utility monopoly. The economic implications alone would be disruptive. Entire industries built around fossil fuel extraction, nuclear power, and even modern renewables would face questions about why we're pursuing these approaches when apparently more elegant solutions existed centuries ago. The political implications are equally challenging for established institutions. Decentralized power generation that anyone could implement and maintain undermines control structures built around energy scarcity and distribution monopolies. If cities can generate their own electricity from environmental sources using architectural features, you can't control populations through energy access or use power distribution as economic leverage. Acknowledging this technology existed means acknowledging that current energy paradigms aren't inevitable or optimal. They're choices that benefit specific interests while imposing costs on everyone else. That's not a conversation institutions want to have, which is why evidence gets classified, researchers get discouraged, and attempts to replicate these systems face bureaucratic obstacles that make implementation effectively impossible despite technical viability. The cultural implications might be even more profound than the technological or political ones. Accepting that this integrated energy network existed requires accepting that a sophisticated civilization with advanced capabilities was subsequently destroyed or displaced, and that knowledge of their achievements was deliberately suppressed or allowed to fade. That challenges fundamental narratives about progress, technological development, and the trajectory of human civilization. We're supposed to believe that advancement is linear. Each generation builds on the previous one's knowledge, technology steadily improves, we're always moving forward toward greater capabilities. But if an advanced civilization existed and then vanished, taking their technology with them, that narrative collapses. History becomes cyclical rather than progressive, and the possibility of civilizational decline and technological loss becomes real rather than theoretical. That's philosophically uncomfortable for cultures that define themselves through belief in continuous improvement and inevitable progress. Which brings us to the obvious question that ties all of this together. What happened? How did a civilization sophisticated enough to build continent-spanning energy infrastructure, standardized architectural technology, and integrated power systems just vanish, leaving only fragments that we've reinterpreted as primitive construction? And decorative elements? The evidence we've been examining points toward a catastrophic event, something that radically altered geography and buried existing infrastructure under meters of sediment and rising water levels. The timeline suggests this happened sometime between the late 1700s and early 1800s, which is conveniently the same period when maps stop showing one version of geography and start showing our current river systems and terrain levels. It's also the period when detailed records become suspiciously sparse for major infrastructure, and many cities show evidence of buried lower levels that official history attributes to gradual accumulation rather than sudden catastrophe. The geological evidence for dramatic change during this time frame exists if you look for it, though it's typically explained away through conventional uniformitarianism rather than acknowledged as indicating catastrophic events. Sediment layers showing rapid deposition, buried structures at depths suggesting sudden elevation changes, river courses that don't match earlier maps. All of this gets interpreted through a framework that assumes gradual change over long periods. But the physical evidence actually better supports rapid, catastrophic alteration. Something caused valleys to flood, created or expanded major rivers, raised ground levels by dozens of meters in some locations, and generally rearranged geography in ways that buried existing infrastructure. Whether this was a massive flood event, a period of volcanic activity creating new terrain, earthquakes shifting ground levels, or some combination of catastrophic factors, the result was transformation of the landscape on a scale that effectively ended one civilization and forced survivors to rebuild in a changed world. The water generators we've been discussing suddenly make perfect sense in this context. They weren't built as underwater structures. They were built as ground-level facilities when valleys were dry and rivers either didn't exist or followed different courses. The catastrophe flooded these valleys, submerged the generation facilities, and forced survivors to adapt by building bridges over the new water bodies. The original function of the structures got forgotten or deliberately obscured, and they were rebranded as bridge foundations because that's what they appeared to support in the post-catastrophe landscape. The decorative elements that seemed pointless on supposedly underwater construction were designed to be visible when the structures were above ground, serving their original purpose as visible infrastructure of an advanced civilization. Everything that seems impossible about underwater construction becomes straightforward when you acknowledge these were originally built in dry conditions before geography changed. The suppression of evidence about these systems starts making sense in this framework too. Acknowledging that advanced energy infrastructure exists buried under our cities and rivers means acknowledging that something catastrophic happened to bury it. That opens questions about what other catastrophes might occur, whether current civilization is actually more advanced than predecessors, and whether the historical narrative we're taught reflects actual events or is a reconstruction designed to support particular power structures and belief systems. Those are destabilizing questions that institutions prefer to avoid, so evidence gets classified, alternative explanations get dismissed, and anyone who points out inconsistencies gets labeled a conspiracy theorist. It's easier to maintain comfortable narratives about continuous progress than to confront evidence of civilizational collapse and technological loss. So here we are, standing at the intersection of physical evidence and institutional denial, with bridges carrying traffic over rivers that hide sophisticated energy infrastructure, buildings topped with dome systems designed to collect atmospheric electricity, and cathedral spires that double as etheric antennas for a power grid we're not supposed to acknowledge existed. The technology is sound, the engineering is proven, the evidence is literally built into our cities. But admitting that means admitting our understanding of history is wrong. Our energy paradigm is backwards, and a previous civilization achieved things we're still struggling to replicate with all our modern advantages. The question isn't whether the evidence exists. It's sitting there, underwater, mounted on buildings, integrated into architecture we walk past every day. The question is whether we're capable of acknowledging it, what that acknowledgement means for how we understand history and technology, and whether we're willing to learn from a civilization that apparently figured out sustainable energy generation at scale, before having their achievements buried by catastrophe and deliberately forgotten by whoever wrote the history that followed. The choice is pretty straightforward when you strip away institutional resistance and narrative investment. We can continue pretending these are just bridge foundations, decorative domes, and religious architecture, accepting increasingly strained explanations for features that don't fit conventional understanding. Or we can acknowledge the evidence in front of us, recognize that a sophisticated civilization built comprehensive energy infrastructure that got buried by catastrophic geographical changes, and maybe consider whether some of their solutions to universal problems like power generation might be worth recovering and implementing. The technology is still there, still viable, still capable of generating clean, sustainable electricity if we stopped actively suppressing attempts to utilize it. The only thing preventing deployment is institutional commitment to maintaining narratives that protect existing power structures and economic models. Eventually, that commitment will crack, either because evidence becomes too overwhelming to ignore, or because practical needs override ideological resistance. Until then, enjoy driving over bridges that used to be power plants, walking past buildings designed as energy collectors, and living in cities that were once connected to an integrated renewable power grid we've spent 2 centuries pretending never existed. The truth is literally built into the landscape. The only question is when we'll be ready to see it.